Hello, welcome. In this short video, let us look at an example illustrating the direct form 1 realization of an IIR filter given from the given system equation. So given the system equation, we want to build the direct form 1 realization of an IIR filter. Direct form 1 realization of an IIR filter. Of an IIR filter. So given the system equation, so in this we look at an example where we have the system equation y of n equal to minus 0.1 y of n minus 1 plus 0.2 y of n minus 2 plus 3 times x of n plus 3.6 times x of n minus 1 and finally plus 0.6 times x of n minus 2. So given this system equation, we want to realize a direct form structure for the IIR filter. So the first step is to build the transfer function or the system function of the filter, that is h of z, and that by definition h of z is given by y of z upon x of z. So to find this h of z, we have to apply z transform to the system equation. That is, by applying z transform on both sides, we get y of z is equal to minus 0.1 minus 0.1 z inverse y of z plus 0.2 z power minus 2 y of z, and then for the inputs we have 3 times x of z plus 3.6 times z inverse x of z, and finally 0.6 z power minus 2 x of z. Now by gathering all the terms of that have y of z on one side and gathering all the terms that have x of z on the other side, we get the following. That is y of z multiplied by 1, and this minus 0.1 z inverse y of z becomes plus 0.1 z inverse, and then minus 0.2 z inverse for the z power minus 2 for the last term, that is minus 0.2 z power minus 2 y of z. And then on the right side we have x of z equal to x of z multiplied by 3 plus 3.6 z inverse plus 0.6 z inverse z power minus 2. So we have 3.6 z inverse plus 0.6 z power minus 2 for x of z, that is terms related to x of z. Now clearly from this equation we can write the system function h of z as 3 plus 3.6 z power minus 1 plus 0.6 z power minus 2, and the denominator is 1 plus 0.1 z power minus 1 minus 0.2 z power minus 2. So that is the system function. Now for direct form 1 realization, we interpret this system function as follows. That is, given the input x of n, it goes through a system h1 of z, that is a system with system function h1 of z, and then it gives an output w of n, which in turn goes through h2 of z, that is the second function, and finally we get output y of n. This is for an IIR system. Now clearly h of z is decomposed as h1 of z multiplied by h2 of z. Note that h1 of z is the all zero system, that is h1 of z is the basically numerator, that is 3 plus 3.6 z inverse plus 0.6 z power minus 2, and the h2 of z, that is the second one, is h2 of z is the all pole system, that is 1 by 1 plus 0.1 z power minus 1 or z inverse plus minus 0.2 z power minus 2. So that is the second system. So we can write the system functions, and now the next step is the relation between w of z, that is the z transform of the intermediate output w of n. So w of z should be equal to h1 of z into x of z. W of z is h1 of z into x of z. So that basically means that W of n is indeed equal to x of n, that is by applying inverse Z transform on both sides. We can easily write w of n as x of n plus 3.6 x of n minus 1 and 0.6 x of n minus 2. So let us call this equation 1. Now similarly for the second component, y of z will be equal to h2 of z multiplied by w of z. So in this case, by simply applying the inverse z transform, y of n will be equal to, since it is a all pole system, it is 1 by 1 plus 0. Z inverse plus minus z 0.2 z power minus 2. This has a recursive system, that is y of n will be, and then minus 0.1 y of n minus 1, and then plus 0.2 y of n minus 2, and finally we have w of n, that is we have plus w of n. So that is the system, that is the equation number 2. So first the input basically goes through an FIR system, we get w of n, and now w of n goes through a system, or basically all pole system, we get the output y of n. So to construct the direct form realization, first we will the system for, or the realization for equation 1, that is up to w of n. That is, we have the input x of n So from the obtained results, that is w of n is x of n plus 3.6 x of n minus 1 and 0.6 x of n minus 2. So this component or this section of the system can be easily built as follows, that is x of n, that is the first component, does not have any delay, so x of n goes to the at the adder, and then we have x of n minus 1, that is x of n minus 1 gets multiplied by 3.6 and again gets sent to the adder, so it is 3.6. Note that there is a 3 here, so x of n gets multiplied by 3, and then x of n minus 2 gets multiplied with 0.6, so we have 0.6 here. So that means the first part of the system is ready, that is w of n is given by 3 times x of n plus 3.6 times x of n minus 1 plus 0.6 multiplied by x of n minus 2, that is we get x of n minus 2 out of this second delay. And for the second component, we have y of n is equal to w of n, so w of n directly fed to the adder, and then second part is minus 0.1 y of n minus 1, so we have y of n going through a delay, that is we get y of n minus 1, and then gets multiplied with minus 0.1, so it is minus 0.1, so that is minus 0.1 y of n minus 1 goes to the adder, and finally y of n minus 2 gets multiplied with 0.2, so we have y of n minus 2 here gets multiplied with 0.2 and goes through the adder. So thus we get the final output y of n. So this is the direct form 1 realization. So to summarize, in this video we have looked at the direct form 1 realization of an IIR filter from the given system equation. So the first step is to find the system function of this, to find the system function. So system function is defined by y of z over x of z. So by simply applying z transform to the system equation, we can derive this system function, which is found to be the ratio 3 plus 3.6 z inverse plus 0.6 z power minus 2 in the numerator, and 1 plus 0.1 z inverse minus 0.2 z power minus 2 in the denominator. And now the direct form 1 realization requires the system to be basically decomposed as one with all zero system and another one with all pole system. So h of z is h1 of z and h2 of z, that is a product of h1 of z and h2 of z. h1 of z is the all zero system and h2 of z is the all pole system. So therefore the intermediate output because of h1 of z is termed as w of n, which is basically going to be equal to 3 times x of n plus 3.6 times x of n minus 1 plus 0.6 times x of n minus 2. So that is the output due to h1 of z. And now for h2 of z, w of n becomes the input and y of n is the output. The relation is y of n is equal to minus 0.1 y of n minus 1, that is the previous value, plus 0.2 y of n minus 2, that is after 2 delays, and finally w of n. So we can build the whole direct form 1 structure by just combining these two systems. So for the first part, we have the intermediate output W of n is equal to 3 times x of n, 3 plus 3.6 times x of n minus 1 and 0.6 times x of n minus 2. And now W of n becomes the input to the second system. That is y of n will be equal to W of n without delays plus, and then a delayed version of y of n minus 1, that is delayed version of y of n, that is we have minus 0.1 into y of n minus 1 and plus 0.2 into y of n minus 2. So that gives the second part of the system. Thus we can build the whole direct form 1 realization from the given system equation. Thanks for watching.